In this video, let us see hypothesis testing using one-way ANOVA. ANOVA is a statistical technique used to check whether the means of more than two independent populations are equal. Let us consider a problem. The following data represents yield of three varieties of wheat from 4 fields with uniform fertility rates. Yield of three varieties of wheat is measured in metric tons in each field. Test whether there is any significant variation in the mean production of wheat at 5% level of significance. Here in this problem, the factors are three varieties of wheat. So here it is a one factor test because we are testing whether the significant variation in the mean production of wheat. So it's a one-way ANOVA. So because here we have got only one factor, so that is we want to test whether there is any significant variation in the mean production of wheat. And here we have taken the samples from 4 fields. They are called as F1, F2, F3 and F4. So totally we have taken 12 samples. From each variety, we have taken 4 samples. So 4 into 3. So we have taken totally 12 samples from 4 different fields. For variety A, 4 samples are taken from the fields F1, F2, F3 and F4. For variety A, in the field F1, the production is 6 metric tons. In the field F2, the production for the variety A is 7 metric tons. Similarly, in the field F3, the production of wheat A is 3 metric tons. Similarly, in the field F4, the production of the variety A is 8 metric tons. So similarly, we have obtained the samples for variety B and variety C from 4 different fields. Now, let us check whether there is any significant variation in the mean production of wheat. Let us take the level of significance as 5%. So now, before starting the procedure of one-way ANOVA, we need to specify the null hypothesis and the alternative hypothesis. The null hypothesis for this problem can be assumed as there is no significant difference in the mean production of wheat. So let us assume the alternative hypothesis. If the null hypothesis is false, we need to accept the alternative hypothesis. Let us consider the alternative hypothesis as there exists significant difference in the mean production of wheat. So now let us construct a table. So X1 is the variety A samples, whatever we have taken from the 4 different fields. And X2 represents here, X2 represents the variety B samples we have taken from the 4 different fields. So similarly, here X3 represents the samples obtained from the 4 different fields for the variety C. So let us consider the sample X1 and let us also calculate X1 square for each samples. So similarly, let us calculate X2 square for each samples obtained from the 4 different fields. So similarly, let us also find X3 square for each samples obtained from the 4 different fields. So as we know, so 6 square is 36. So 7 square is 49 and 3 square is 9 and 8 square is 64. So similarly, 5 square is 25 and 3 square is 9 and 7 square is 49. So here 5 square is 25, 4 square is 16, 3 square is 9 and 4 square is 16 and 4 square is 16. So now what we shall do is we shall add all these samples, total of all these samples. So 6 plus 7 plus 3 plus 8. So we get it as 24. Similarly, total of 36, 49, 9 and 64 is 158. So similarly, obtain the total of 5 plus 5 plus 3 plus 7, which is equal to 20. Similarly, total of 25, 25 plus 9 plus 49 is 108. So 5 plus 4 plus 3 plus 4, the total is 16. So total of 25 plus 16 plus 9 plus 16 is 66. So in this way, let us make the table first and foremost. After this, let us follow the algorithm of one-way ANOVA. So first and foremost, the algorithm says find the total of all the samples. So hence, the total of all the samples is total of x1 plus total of x2 plus total of x3. As we have already found out the total of x1, which is equal to 24, and total of x2 samples is equal to 20, plus the total of x3 variety sample is 16. So when we add all this data, so we will be getting the total sum of individual items of in all the samples as equal to 60. So this is the first step. In the next step, we need to find the correction factor. Correction factor is given by total is equal to t square divided by n. So what is our t? So we got the total of t value as equal to 60. So now t square, that means 60 square divided by n. So what is this n represents? N represents total number of samples we have collected. So here we have got 4 samples from the variety A from the fields F1, F2, F3, F4. Similarly, 4 samples for the variety B. Similarly, 4 samples for the variety C. So totally we have got 12 samples. So therefore, the value of n is equal to 12. So now 3600 divided by 12 is equal to 300. So the correction factor value is equal to 300. After this, find out SST, total of sum of squares. So which is equal to x1 square plus x2 square plus x3 square. So this already we have done in our previous table. So x1 square is 158. Total of x2 square is 108 and total of x3 square is 66. So substitute all that values and minus with the correction factor, we get SST value is equal to 32. So after this step, let us find out now SSC. So SSC is given by total of x1 whole square divided by n1 plus total of x2 whole square divided by n2 plus total of x3 whole square. This is x3 whole square divided by n3 and then minus all this data with the correction factor C. So x1, total of x1 we have already got here. Total of x1 is 24 and total of x2 is 20 and total of x3 is 16. So substituting all this, and here divided by n1. What is this n1? You can see here. So in the samples for the variety A, how many samples we have taken? We have taken 4 samples. So this represents our n1 value. So small letter n1 represents 4, which is equal to the number of samples collected individually for the variety A. So similarly, in this problem, since we have taken all equivalent sample in all the 4 fields as 4, 4, 4. So in all the data, in here for everything we need to substitute as 4, 4 and 4. So totally calculating, we get sum of squares among the column as equal to 8. So next step is find the sum of squares of deviation for residual or find the error variance. So error variance is given by the formula SSE. SSE is equal to SST minus of SSC. So previously we have calculated our SST. SST is 32 and then we have calculated SSC, right? So SSC as 8. So therefore 32 minus 8 which will be equal to 24. So after that find the degrees of freedom. So degrees of freedom is given by the formula V1 is equal to K minus 1 and V2 is equal to N minus K. So what is K here? K is the group. So how many groups are there? We have got 3 groups, right? So variety A, variety B, variety C. So we have got only 3 groups. So therefore, our K value will be equal to 3. So therefore, 3 minus 1, we have V1 is equal to 2. So what is our V2? V2 is N minus K. So N is the total number of samples collected. So N is equal to 12 and K is equal to 3. So therefore, our V2 value is equal to 9. So next step is find the variance or mean square between samples, and that is given by the formula MSC is equal to SSC divided by V1. So we have already calculated our SSC value as equal to 8 and our V1 value is equal to 2. So therefore, substituting and simplifying, we get the value of MSC is equal to 4. So next step is let us find variance or mean square within samples, and that is given by the formula MSE is equal to SSE divided by V2. So SSE we have already calculated, right? So SSE is 24 and our V2 is equal to 9. So substitute that and then simplifying, we get the value of MSE as equal to 2.66. So after this, let us apply the F test. The F test or F ratio is defined as MSC divided by MSE. So MSC is 4 here. We have already calculated MSC as 4 and MSE as 2.66. So substituting and simplifying, we get the value as 1.503. So what is this value? This is nothing but the calculated value or F test value calculated. So now we have to, since our level of significance we have taken in the problem as 5%, we need to find the standard value. The standard value can be found from the table. Okay, the table we need to check at the 5% level of significance, and then we can see here our V1 is 2 and V2 is 9. So now let us see here in the table. So V1, right? So V1 is 2. Here V1 is 2 and our V2 is 9. This is our V2 values and V2 is 9. So correspondingly, so we get the level of significance value, the standard value as 4.26 at 5% level of significance. Now let us compare whether our calculated value is lesser than the standard value or not. Okay, so the calculated value is 1.503 and our table value is 4.26. So since the calculated value is less than the standard value, the null hypothesis is accepted. So what's the null hypothesis? There is no significant difference in the mean production of wheat. So this is how we calculate the, we verify the problem with the help of ANOVA table, whether the null hypothesis can be accepted or not.